So here's a laboratory test that is aimed at sort of getting at some of these dynamics of sort of understanding the rules for successful behavior and being able to respond appropriately. This challenge may be familiar to some of you who've taken psychology courses, perhaps even experienced this test yourself. This is called the Wisconsin card sorting task. And what's going on here is that a subject has to sort a deck of cards by placing these cards into one of a few different piles based on some kind of rule, some kind of sorting rule that is never made explicit to the subject. Only by feedback on each trial is this subject informed of the rules by which sorting must occur. So one can imagine with a set of cards such as this, one can sort by the color of the card, putting all the red cards in the same stack, all the green cards in a different stack, and so on. One can imagine sorting by shape, where all of the cards that bear star shapes are put together. All the cards that bear triangles are put into the same pile. Or one might imagine sorting by number, with all the cards that have one object on them put together, and all the cards that have two are put in a separate pile, and so on. Now, the key to this experiment is that the rules for sorting the cards are determined by the person running the experiment, and the subject is only provided feedback about whether the sorting of the card was correct or incorrect according to whatever rule is in effect. So the way this might go, for example, is that the experimenter may decide that the sorting rule is going to be by color. And so the subject begins to sort, and the experimenter may say correct, correct, incorrect, 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 and with some number of negative feedback prompts, then the subject might realize that maybe the sorting rule has just changed from sort by color to perhaps some other scheme, such as sort by shape. And by giving this feedback following each placement of a card, the subject accrues the knowledge that will guide future behavior until there is negative feedback again that prompts a change. So you can imagine what would happen with patients that have problems with their dorsolateral prefrontal cortex. They tend not to be able to integrate these changing sensory signals that would guide now appropriate behavior. They have difficulty integrating these signals to guide appropriate behavior in the future. As a consequence, these individuals tend to perseverate, meaning they tend to repeat the same behavior even when the rules that would shift behavior have changed. So if a person who had damage to this dorsolateral sector of the prefrontal cortex was tested in this Wisconsin card sorting task, we may find perseverative behavior. They may continue to sort according to a particular rule that may seem to be working and reinforced, even when those rules for reward and punishment may change. So these subjects have great difficulty suppressing what is now an inappropriate behavior because of a failure to properly integrate the cues that are helping to establish an appreciation for the rules that ought to moderate our behavioral choice. Well, I want to take you through a few slides that illustrate in a simple way the functions of this dorsolateral prefrontal cortex, and it gives us a chance to maybe feel a little of the dissonance in ourselves that is an indication that this network is actually working correctly. Now, I'm going to use color here, so I apologize to those of you that have some deficit in color vision. I hope you can still follow along and appreciate as best you can. But here's what I want you to do. I want you to simply report the dominant color that you see on the next sequence of slides. And go ahead and say it out loud. I'll say it with you, okay? So here we go. Red, green, blue, red, green, blue, green, blue, red. Now, I've been practicing this for the last couple of minutes, and you might have experienced what I just felt, which is just a little bit of dissonance as we read a certain bit of text and our vocalization is not what we have read, but rather the color of the type that we see before us. So it's a bit of a challenge for me to look at this red-lettered blue and report the color without simply reading the word. So this is what our dorsolateral prefrontal cortical network is doing for us. It's helping to maintain in working memory the rule that's motivating behavior. In this case, the rule was to report the dominant color. There are a variety of other behavioral options that are before us at all times. And sometimes it's very tempting to deviate from the appropriate behavior and let loose what would be a behavior that perfectly legitimate, but it would violate the rule under which we are trying to operate here. So people with damage to this part of their prefrontal cortex would have great difficulty suppressing the dominant cues that would guide their behavior. And in this simple version of a dorsolateral prefrontal test called the Stroop test, often the dominant signals come in the form of the written word, the text. So it would be very difficult for a person with damage to this part of the brain to read the word blue in red type and do anything but report that word blue. So now I think we're ready to leave this dorsolateral sector of the prefrontal cortex and spend just a few minutes introducing the orbital and the medial aspects of the prefrontal cortex. Now, these parts of the associational network of the frontal lobe bear many functional similarities to what we've just been describing for the dorsolateral sector, but there seems to be some very important differences that pertain to the inputs and outputs of these cortical networks relative to the sources of the information and the effector systems that they gain access to. The dorsolateral prefrontal cortex is working on explicit information. That is information derived from our special sensory systems, from our memories, from other aspects of cognition that we can access with our language systems. We can talk about them, we can give them names, we can describe them with our verbal faculties. The orbital and medial sector of the prefrontal cortex, however, seems to be operating principally on implicit information. Information derived from our emotions that are informed by our visceral senses. Information that is united through these prefrontal networks with our faculties that are involved in planning for the future, but those plans are being motivated by these sources of information that are just more difficult to describe. Consider, for example, the challenge of articulating in verbal terms the content of an emotion, such as anger or fear or happiness or sorrow. I can do a much better job describing, for example, the texture, the dimension, the color of this object that I'm holding in my hand than I can use my verbal faculties to reveal for you the content of the twinge of anxiety that I may be feeling at this very moment. So our orbital medial prefrontal cortex is engaged in the processing of emotion and integrating that emotion with our faculty for reason, for decision making, for planning for the future, both our short-term as well as our long-term. And it's this future thinking aspect of associational processing in the prefrontal cortex that can lead to advantageous decisions as our lives unfold, or perhaps disadvantageous decisions if our motivations are simply driven towards short-term gains, impulsive action. So part of what this orbital medial prefrontal cortex does is suppress the impulses that might lead to the acquisition of short-term gain at the cost of a more long-term strategy that would lead to advantage, be it in the domain of social relations, in financial matters, or whatever the dimension of life that we might want to consider. We're going to have much more to say about this orbital medial sector of the prefrontal cortex when we talk about emotion. And we'll consider how the amygdala in the anterior part of the medial temporal lobe has an important role to play in the experience and expression of emotion, and how the amygdala is intimately connected to this orbital sector of the prefrontal cortex. Now, a modern understanding of the importance of this orbital and medial part of the prefrontal cortex and integrating emotional experience with our decision-making faculty began with the story of one individual who passed away about 150 years ago. His name was Phineas Gage, and I'm sure he's known to many of you. Phineas Gage was an individual who suffered a horrific injury to the front part of his cranium, involving facial structures and, amazingly, a huge penetrating injury to the cranial vault that resulted in damage to the orbital and medial sectors of the prefrontal cortex. Now, this injury was reported in the local newspaper in Rutland, Vermont. That paper was called the Vermont Mercury, and one Friday edition in 1848, October 13th, led with the headline, "A Wonderful Journey Through Skull and Brains." Well, much has been written about Phineas Gage, especially in the last decade, where we recognize Mr. Gage as really the pioneer of a new cognitive science that has led to a deeper understanding of the brain mechanisms that integrate emotional experience into our decision-making faculty. And arguably, contrary to major streams of thought, at least in Western philosophy, emotion and reason really need not be at war with one another, but rather in the integrated actions of our associational networks of the prefrontal cortex, we see that emotion and reason really work hand in hand to guide our decision-making in real-life situations, especially when there's some risk involved, when there's something at stake. The idea that we're going to elaborate in a subsequent tutorial is that emotions play a critical role in biasing our decision-making faculties. And I think there's mounting evidence to support this view. Still quite controversial, but nevertheless, I think it's giving us a much more integrated sense of how emotion and reason work hand in hand to moderate behavior. So I look forward to having that discussion with you as we explore the emotions and the brain mechanisms that come around the experience and the expression of emotional behavior. So until that time, I hope you have an interesting moment reflecting on the study question that I'll leave you with. And perhaps it might be necessary for you to review just a little bit of anatomy, especially with respect to the dura mater. That's a bit of a hint. So I'll see you next time as we pick up the story of complex functions of the human brain.